Hi, and welcome to this tutorial. This is either the 6th tutorial in the Monty Hall and the Python series, or you're watching this maybe as a one-off, where I'm just showing you a trick where you can generate kind of what could be an infinite sort of list of strings of letters in an ordered sequence. And so, why am I doing this for the Monty Hall tutorial series, or why am I doing this as a one-off? I don't know. It seemed like an interesting little trick that I picked up at some point, and I thought it was worth putting on here, and so why not? So if you haven't, go back and watch the first in the Monty Hall and the Python tutorial series, and by now you should have, if you've watched all of that, you know exactly how the whole Monty Hall problem works and why our simulator demonstrates it properly. And so here's just a few little bells and whistles. When we left that tutorial, we had a list of choices that I just generated right here, where it says our choices were I for I in range 100. So we had 100 choices, and that I thought was the simplest way to generate a unique list of choices. Our original choices, you can see, were A, B, C, etc. And maybe it seems a little more pleasant to have choices that were A, B, C rather than just 0 through 99. And that's totally arbitrary, but maybe you want to do that. It doesn't enhance the problem at all, but it does, I don't know, it gives you something to work on. So to do this in an interestingly simple fashion, we'll start at the top here where we're going to import something called string. So import string. And now that we have string, we're going to generate an alphabet. And since I like the uppercase alphabet for this particular instance, we're going to just say alphabet, equals, and we're gonna make it a list. String.ASCII underscore uppercase. All right, so what that's going to do is that's going to give us the ASCII uppercase, and then Python will generate that into a list. So we'll just have A to Z all in uppercase. Okay, so now we have the alphabet as a string. The next thing we're going to want to do, we don't have to get rid of this, but we'll say we want to know how many choices that we want. So to make it equal to this, we'll say how many choices equal 100. So this variable is now substituting for this value that we're having up here. All right, now we're going to do a little bit of loops and logic. So we're going to start off, we're going to need two indices. We're going to say I equals 0 and j equals 0. And we're going to have two while loops. While loops are interesting. They do a lot of good things. If you don't code them properly, they can get stuck in infinite loops, and then you have to break out of your code manually if you can. So I guess, I don't know, maybe it's bad practice to use while loops. I don't care. We're going to show you one now. So actually, I guess before we do starting the loop, we need to take the length of our original alphabet. You might know that there's 26 letters in the alphabet, but just in case, maybe you want to do a list of the uppercase and lowercase letters for some random reason, and we could do that. So you can just start with whatever you have as as your original alphabet. You can just say len. I'm calling it len orig equals the length of the alphabet. Okay. So this alphabet is our list. Len is a built-in function in Python that takes the length of a list, and so that computes what we need right there. Okay, now we can start our two while loops. So while the length of the alphabet is less than how many, choices. So we want the alphabet to at least be as long as how many choices we have. So while it's less than that length, what are we going to do? We're going to start another while loop. While I is less than len orig, and the length of the alphabet is not equal to how many choices. Alright, so what are we doing there? Okay, we're saying that as long as I is less than the original length of the alphabet, and as long as the length of the alphabet currently is not the same as how many choices. That way we have some criteria that will kick us out of this loop. So while those two things are true, we're going to say alphabet dot append. And what are we going to append? We're going to append alphabet J plus alphabet I. Well, so what is this going to do? Right now, I and J are 0. Alphabet J and alphabet I are both the first entry, which should be A in our alphabet. And so then after this, we want to iterate on the one we're looking at up in here at where it says I less than len orig. So the I less than the original length of our alphabet. We'll say I plus equals 1. That means that while we stay in this loop, as long as we're not equal to how many choices, then this alphabet I will iterate by 1. So originally we're AA, then we'll be AB, AC, AD, and so on. Okay? Then once we exit this loop, we want to add 1 to J. Okay? So then we'll start BA, BB, BC, BD, and so on. And we want to reset our I counter. I equals 0. Okay? So once we finally get through that loop entirely, or I mean, you might just skip this loop. If you only want 10 choices, then we'll never enter this while loop because we started off saying, well, the length of the alphabet was less than how many choices we want. So as long as how many choices, I guess, that should be less than or equal to. No, it doesn't matter. We'll see. I think it doesn't matter. Anyway, as long as the length of the alphabet is less than how many choices, then we're all fine. So then once we've finally gotten out of this loop, we'll redefine choices. It was defined up here. Now we'll define it again, kind of overwriting it. Now choices equals alphabet. And we're going to use this kind of slice operator here that's saying everything from 0 up to some length, and we'll say that length should be how many choices. Now, this should basically, you know, if how many choices is 100, we've just ensured that the length of our thing is 100 choices long. So this is the same as just saying our choices equals alphabet. But what I found is that if you changed your choices from 100 to 10, you don't want to have all 26 letters in your alphabet. You just want to have the first 10. And so that is the reason that I do this like this. That way this will make it a list that's exactly the length of the number of choices you want to have. This all seems like a fairly, I don't know, long and drawn out way to do something that doesn't add any value to understanding the Monty Hall problem. But again, that's we've solved the Monty Hall problem. We're over that. Now this is just kind of a for fun way to figure out how to make lists of the alphabet. So now we want to print this to the screen just for our own amusement to see what's happening. So we'll say print alphabet, and just to be sure, we'll say print the length of the alphabet. Okay, and then we'll say sys.exit. And that'll just make sure that our code executes all the way down to here and then stops, just to find out if all the stuff we did here works the way we want it to. So we imported string, we got the alphabet, we designated how many choices, and then we go through all this stuff and we exit here. So let's try this out. We're going to save this as Monty Hall tutorial _ number 4. And so we'll go over here, Python Monty Hall tutorial 4. Okay, we have an error. While len alphabet less than how many choices, name how many choices not defined. Did I not define it? I just said how many choice versus how many choices. Okay. That's part of the reason I like using Notepad++ is that has this highlight feature where if you highlight something, it shows you all the other times it shows up. And sometimes maybe you get in trouble if there's some case differences, but in this case, there was a spelling difference. I put choice instead of choices. Anyway, now we've found the problem. Let's try that again. And there we are. So what do we have? We have something that's 26 length long. And now why is that? Because I printed alphabet and not choices. Hilarious. Okay. So obviously that's a good example that computers do what you tell them to do and not what you want them to do. All right. So there we go. A, B, C, D all the way to J, and we have 10. Now, if we crank up our choices to 1,000, let's see what we get. So boom, now we have all these letters. Our length is 1,000. We end with the word all. And you know, I've actually, you can take this up to any number you want to. Of course, what do you get when you go to 2,000? Yeah, this one's funny, right? You got but, bus. You have some actual words in here. You know, you'd find all the BU words, bud, bub. Anyway, now I'm just being, there's the symbol for Bitcoin. I'm just being ridiculous now. Anyway, the other thing that's neat about this is that you really haven't changed anything in your whole Monty Hall code. And so we've just changed what our choices are, what they look like to the code. So the code now gets to pick. So we can get rid of this here. And again, if you haven't seen the entire Monty Hall problem series, I urge you to go and check that out. But we'll see if we can even endure. We'll take this down to just 100 simulations with, let's see, 2,000 choices, and we'll change how many reveals to be 1998. So that's the maximum right there. How many reveals has to be the number of choices minus 2 at least, because you choose 1 to start with, and then Monty Hall has to leave 1 door for you to open at least, and so it's the total number of doors minus 2. Okay, so we will see this. You know, basically we should guess the right thing every time, because it'll be if we switch, right? We were saying switch equals true, so we're always switching our answer, so we should almost get 100% correct. Let's see. But it might actually take it a long time to run, because it's going to run through this thing. Oh, well, it wasn't that bad. We were right 100% of the time. 100 out of 100 times. Wow. We have amazing accuracy at guessing out of 2,000 random choices. We're just lucky that Monty Hall revealed 1,998 wrong choices. So, all right. Well, thank you for watching this. And again, if you don't understand why we were right 100% of the time, go back and watch the whole series. There's only 5 little tutorials in the series. Besides, this one's number 6, because you can count. All right, thanks for watching. See you in the next one.